Welcome, this is lesson 8.3, composition of functions. Let's get started. So what exactly is a composite function, right? You might have heard that composite function is a function inside a function, but what does this actually mean? So first we're going to define some new language in relating to functions. So a function f of x, we say it's a function f with respect to x, or f as a function of x. So this means that x is an input of the function and fx is an output of the function. So you put x into the function and you get some fx out. So with the same logic, f of g of x, a function that looks like this, is a function f with respect to g, or f as a function of g. So gx is an input of fx and the output is f of gx. So we can think of this like a function machine. So you have x, you input the first input into the first function machine, and then the output is g of x. The output of g becomes the input of f, the outer function. So the output of the inner function is the input of the outer function. And when you input it into the second machine, second function, it turns to, it outputs f of g of x, or f of gx. So yeah, that's kind of how the composite function works. Just think of it like inputting stuff into subsequent machines. It should make more sense. Some things relating to composite functions, you might see it written with this dot in between, and this just means the same thing as f of g of x. It's just a different notation. Also, if you switch the order, it's not the same thing, and you can try out with like two functions by yourself to see why this is the case. The second thing is that since g of x is an input of f of x, the composite function is defined only if g of x is defined. So if your input is undefined, then your output is undefined. So the domain of f of g of x must be within the domain of g of x. And also, because g of x is an input of f of x, the value of g of x must be in the domain of f of x. Because if your input value is not in the domain, then you don't have a defined output. So f of g of x is only defined if g of x is in the domain of fx. Let's do that and try some example questions. So you can pause the video and try this out on your own. Okay. So first, question A, we want to find f of g of 4. So we note that g of 4 equals 5. Oh, this one should be f. G of 4 is 5. So f of g of 4 is f of 5, and f of 5 is 10, so the answer is 10. The second question, f of g of 4, we're asked for again. G of 4, if we look here, is 2 because of the 0.42. So we are trying to find f of 2. And if we look over here, the answer is 3. Last question, we want g of negative 2. Or we want f of g of negative 2 and f of g of 0. So first we note that g of negative 2 is negative 1/2, but negative 1/2 is not in the domain of f of x, because it's the square root function, which, if you recall, requires x to be greater or equal to 0. So f of g of negative 2 is undefined. And g of 0 is undefined because you're dividing by 0, and you can't do that. So if g of x is undefined, then the whole composite function is undefined. Whoops. So question C is relating to these two rules that I said before. And alternatively, what you can do is just substitute the expression for g of x into the expression for f of x. So you're substituting 1 over x into the square root. So this is the algebraic method. You're substituting g of x as the input of f of x. So normally the input is x. So if f of x equals x squared, g of x equals x plus 1, the g of x replaces this x. So then f of g of x is g of x squared, which is x plus 1 squared. Example 2. Alright, you can pause the video and try yourself. Let's get into the second example. So for A, determine, we're asked for f of g of x. So we just substitute g of x into f of x, so we get something that looks like this. And again, we can factor it, the denominator. And so the domain of f of x is 1 over f of x equals 1 over x. Is x unequal to 0. So that means that g of x cannot be 0. And so x is unequal to plus or minus 2. And we can also just look at this as a rational function and determine this. So the domain of f of g of x is x is unequal to plus minus 2, x for all real numbers. For B, remember a composite function is when you have one function inside another function. So one possibility could be f of x is log x, g of x is 3 times x plus 5, because when you sub this into f of x, it makes the required function. And second example is the same thing. If you sub x plus 5 into log of 3x, you get log 3 times x plus 5. So these two are the possible pairs of functions that make up this composite function. Now we have a composite function involving inverse of a function. If a function f of x has inverse gx equals the inverse of f of x, then f of gx equals g of fx equals x, if and only if g of x, or the inverse of fx, is a function. So f of x must pass the vertical and horizontal line test. Why do we have to do this? Because the inverse basically reverses the process of the original function. So the original function turns x of all values to y values, and the inverse turns y values back into x values, or in other words, it switches the x and y values. So since to see if fx is a function, you do a vertical line test. Since the x and y values are switched in the inverse function, it would be a horizontal line test to see if the inverse is a function. Now, what if the inverse is not a function? If the inverse is the inner function of the composite function, then there's multiple possible f inverse of x. So there's multiple, remember this inverse is the input of the outer function. There's multiple inputs, then there has to be multiple outputs. And if the inverse is the outer function, then you have one input, but again you have multiple outputs because it's not a function. Remember, the definition of a function is that there's one y for every x value. If the inverse is not a function, we cannot say that this identity is true, right? If we have some point a, b on y equals f of x, normally if the inverse is a function, then for this composite function, you input a, and you get b for f of x, and then when b goes into the inverse function, oh wait, no, this thing is if the inverse is not a function, sorry. If the inverse is not a function, then you input a and you get b for f of x. But if the inverse is not a function, then you might get a, but you might also get something else. And again, if the inverse is not a function, and if it's inside, then you have some point a, and then you can have, for the inverse function, b or some other value. And then if you evaluate the composite function, you can go back to a, possibly, or you can go to some other value. So you can't say for sure that the composition of a function and its inverse equals x if the inverse is not a function. Okay, look at this question and pause the video and try to do it yourself. So for the first question, we have f of x equals 3x plus 1. Gx is the inverse of fx, and we want to determine this. So we determine the inverse of f of x equals x minus 1 over 3. And both of these functions are linear equations, so they're functions. Therefore, we can use the identity that f of g of 3 equals g of f of 3 equals 3. Second question, note that when you find the inverse, you have to take a plus minus square root. So this is not a function. The plus minus square root graph is not a function, so we cannot use the identity. So we have to do it normally. If we sub in negative 2 to f of g of x, then g of x is a square root, so square root of negative 2 is undefined. So this function is undefined. But if we sub it into g of f of x, it equals this function. Algebraically, you're just subbing in x squared into the square root function. So the square root of negative 2 is 4, and then the square root of 4 is plus minus 2. So you can see that these two values are not the same because the inverse is not a function. Part 3, application of composite function. So basically what you want to do for this is determine a function for the required thing in respect to the other required variable based on the information given. So a movie theater has rooms that seats 100 people each at max. Each movie ticket costs $6. Create a function representing total revenue in respect to number of rooms filled. How many rooms must be filled to make at least $1,500? Again, you can pause the video and try this out yourself. Alright, so we define R to be total revenue, P to be number of people, and lowercase r to be number of rooms filled. So capital R equals 6p because each ticket costs $6, and number of people equals 100 times lowercase r because each room has 100 people. And then to make the composite function, we just sub in the inner function into the outer function. Remember, p is as a function of number of rooms, and the revenue is a function of the number of people. So we do the substitution, and we get revenue as a function of number of rooms equals 600 lowercase r. And for B, we need to have revenue at least $1,500, so greater than or equal to $1,500. And then we just sub in the function, and we find the value of lowercase r to be 2.5. But since the room has to be filled, the number of rooms has to be a whole number. So we round this up, because if it's 2 rooms, then it'll be less than 1500. So it has to be 3. So therefore at least 3 rooms must be filled. Question 2. Forest fires spread in roughly circular patterns. A fire starts in a certain forest and the fire's radius increases by 0.5 kilometers per day. Model the area of the fire as a function of number of days. Determine the area burned on the 6th day. So first we let A represent area in kilometers squared, R represent radius in kilometers, and T is the number of days. So A, we know that the fire's in circular pattern, so the area is the area of a circle, pi r squared. And R equals 0.5 T, 0.5 kilometers per day. We create the composite function by subbing in R into the function of A. And then we get A of T equals pi over 4 T squared. The area burned on the 6th day, you just sub in 6 into the area function and you find the answer. Question 3. A group of 150 people decide to disobey COVID-19 rules and start to party once a day without masks. 3 of these people are currently infected with COVID-19. With their current rate of partying, the number of infected in this group doubles every 4 days. Each of these people have 2 other family members and don't physically distance with them. So all family members will also be infected too on the same day. This is what we're asked. You can pause the video and try to figure it out yourself. Okay. Alright, for part A, we let D be number of days, P is the number of infected at the party, and T is the total number of people infected at the party and in the household. So there's 2 other family members, so the total number of people is 3 times the number of people infected at the party. There's 2 family members plus 1 person at the party. And P equals 3, the initial value of the initial number of people infected, and 2 to the exponent of D over 4 because it doubles every 4 days. So we create a composite function to be 9 times 2 to the exponent of D over 4. For B, this should be 180. For B, we want to know how long until 180 people are infected. So we sub that in and then we solve for D. So we divide both sides by 9, use natural logarithm, and use the property that you can bring this exponent out to multiply by the logarithm. And you can use any logarithm, but I just use natural logarithm. And then we solve for D. It's around 17.2877 days. What is the range of T of D? Since initially 3 partygoers are infected, plus their families, minimum of 3 times 3, or 9 people are infected. Also 150 people are at the party, and each person has 2 other family members, so maximum of 150 times 3, or 450 people can be infected from this event. So the range of our function is T is greater than 9 and less than 450. And also T is an integer because you can't have fractions of people. And this is not affected by the mathematical range of the function, which is 0 to infinity. So mathematically, this just requires T to be greater than 0 because of the exponential function, but because of like real life restrictions. And because of the restrictions given in the question, we have this domain or this range for the function. Alright, question 4. A Ferris wheel has a radius of 20 meters and is 5 meters above the ground. Its angular velocity is 15 degrees per second. Model a function for the height above the ground of a passenger in respect to time. Let t equals 0 be the lowest point of the rider. What is the height of the rider 8 seconds after the Ferris wheel started turning? And here's a diagram of the situation.